Good to go? All right. Well, I think we're going to get started here. A few minutes early, so we got a lot to go over in a short amount of time, so let's get going. So today, we're going to talk about honeypots for active defense. And so, let's jump right into it. First, a little bit about me. My name is Greg Foss. I'm the head of security operations at Logarithm, also a senior security researcher with Logarithm Labs. So we get to do a lot of fun stuff, right? So some of that fun stuff is honeypots. So first, let's take a look at traditional defensive concepts, right? These are the things that most people are currently doing within their organizations right now to actively protect them, right? So first and foremost, maintain a tough perimeter, right? You want to have a hard outside, make it hard for attackers to get in, right? And then implement layered security controls. You want it to be tricky for them to get in, get further, pivot, all that stuff. You have your IDS, your WAF, all that good stuff in place, right? And then you want to block all the stuff you know about, all the known virus signatures, all the known IDS signatures, all the stuff that you actually can detect that you actually know you're probably going to get hit with, right? And then we want to create and enforce policy so that our users, that we actually protect our users, we keep them from accessing things they shouldn't, stuff like that, right? And then we hope that all of this stuff actually works, right? We pretend it does, but really it doesn't at all. So, like most of the people who are near pen testers, there's always a way in, right? It's not like even working for a vendor, we're not going to come and tell you like, hey, you can buy any security product and it's going to magically protect you, right? So there's always going to be this dude, this guy right here, just clicking on stuff. There's always some way into an organization. So you have to have, not just the right tools, but you have to have people trained and ready to respond to this stuff, people willing and able to actually help defend your network. And it's not just the APTs, right? It's not just the, attackers from the outside that you have to worry about, because your inside employees can be bought. Like, people can always be paid enough to sell your trade secrets. People can get phished, then all of a sudden there's someone on their system. They're already inside your environment. Like most of the environments we go into and help people out, we find out, there's already someone inside their network. They've already been breached in some way. So that's why this whole talk was kind of created, was looking more inward, looking at like what's going on inside your network and trying to find some ways to dynamically catch some of these attackers, right? So that's why I like active defense. Oh yeah. So what is active defense? Right? So it's exactly what it is right there. So what I mean by active defense is simply, tipping the odds in your favor, making it, a lot harder for attackers to penetrate your networks. You want to do this by annoying them, creating false systems, creating false services, stuff like that that's going to just actively dissuade them from the real targets, right? And then trap them. Get them caught in your little fishnets, essentially, and learn from them. Figure out what they're doing, what they're after, where they're coming from, where they're going, all that good stuff, right? And then that's how we gather data on them and actually learn, more about who these people are and what they're after. And then using that information, we can better defend them. And the last phase is actually attacking back. And I don't mean like popping shells on attackers and stuff like that, because you can cross the line there, but within reason, there are a lot of things you can do back to the attackers, essentially. And essentially, all this comes down to reducing your mean time to detect attacks and then mean time to respond. So you want to minimize that as much as possible. And so I really like this quote here from Sam Quigley. It's just the goal of security engineering is not to make compromise impossible. The goal is to make it expensive, difficult, and noisy. And that's essentially what we're doing here. So why internal honeypots? Why do we want to use internal honeypots for this? Well, one nice thing with honeypots is there's tons of them out there, and they're really easy to configure and deploy and maintain. Essentially, these are just fly traps in your organization. They sit there and wait for weird stuff to hit it. And the cool thing about internal honeypots, as opposed to like external research-focused honeypots, is internal ones, the most you're looking for is for someone to raise a flag, essentially. You want to trigger an alarm when they do something so you can respond. And this may be, something that if they did this to a normal system, you probably wouldn't even notice it. But since they're interacting with one of your honeypots or using a honey token or something like that, it's something very odd, and it gives you kind of something to follow up on. And the nice thing about this is you're going to learn a ton about your attackers once you start deploying internal honeypots and actively watching what's going on in these systems. The key, though, with honeypots is these are kind of something to focus on after you already have the basics in place. Like after you have, standard baseline security controls, stuff like that, that's when you can start looking to implement honeypots. So what are some use cases for honeypots? Primarily research. This is how a lot of those threat lists are generated. This is how a lot of the companies out there are generating data to help better generate rules and stuff like that for their products and things like that. But defense is primarily where we're going to focus today. And that's using honeypots in a way that not a lot of companies are doing right now. So, defense. So to help out with that, there's actually quite a few virtual machines out there that you can deploy for free within your environment to mess with honeypots and start figuring this stuff out. The first one's HoneyDrive 3, which is a pretty cool project. I wouldn't recommend this for like an actual enterprise defensive deployment though, because this isn't the system's not very well hardened at all. It's more open and like a test bed for playing with various honeypots. So you can go in there and figure out like what honeypots you want to use on other systems in a real way. This one, if someone starts poking at it, it's a dead giveaway right away that it's a honeypot because it says honeypot everywhere, like on all the web interfaces and stuff like that. So you have to be careful, but it is something good to learn from. Now, the one I do like using in actual defensive scenarios is ADHD. The Active Defense Harbinger distribution. Now, this is by Black Hills Information Security and Secure Ideas. Both those companies are here, and like a lot of the people that actually helped create this are actually at the conference right now. So if you find them, you should definitely ask them about ADHD because it's a very powerful tool. And it's actually, employs a lot of different honeypots, but it also has active defense tools so you can attack back at the attackers as well. So very cool project. Highly recommend you check it out. But first things first, before you start deploying any of this stuff, before you start tracking attackers and watching what they're doing and launching client-side code on their systems and stuff like that, you want to deploy warning banners for all the systems in your environment. This gives you leeway so that when people are logging into these systems, legitimately or illegitimately, they're having to go through a warning banner that essentially says, hey, you agree to these terms. Because whether you like it or not, attackers actually have rights even though they're inside your company. So if you pop a shell on them, but you didn't have them go through an approval that says you can do something like that, you can actually get in a little bit of trouble for that. So it's just something to keep in mind. So what are some types of honeypots? This is kind of my breakdown of honeypots. There's a lot of different varied viewpoints on honeypots out there. So this is my interpretation. So no interaction. These are essentially honeyports, just basic services that sit up there and either log or block based on interactions with those ports. And then low interaction. These are the ones that are very basic. They serve up a basic flat web page or something like that. Not a whole lot going on there. Medium interaction are kind of the most popular honeypots. These are the ones that actually simulate real services. It'll be like SSH or FTP or Telnet or something like that. And then high interaction. These are more like actual real systems or systems that are set up to imitate real systems. So essentially trying to imitate every aspect of the operating system. And then my favorite ones are honey tokens and honey drives and strings and stuff like that. Because these are the ones that you can actually get a ton of traction from. And I'll show you in a little bit what I mean by that. So no interaction honeypots. Let's dive into these first. So these are essentially just honeyports. The cool thing about these is they're very easy to build and deploy. It's like this Linux example here. This is actually from the ADHD CD. And it's also in the Offensive Countermeasures Art of Active Defense book. So I highly recommend that book as well. But right here, just a couple lines of bash, you've effectively created a honeyport. Now what this does, right here, we're just simulating FTP. And that whenever someone connects to this, it just blocks them from the host, just using local IP tables. Very simple. You can also do the same thing on Windows, just using netcat and netsh, just a few lines of code as well. So really easy to build out, and then you can simply push these out to other systems within your environment. But then when you really want to get into some more, a little bit more in-depth honeyports, there's actually Python and PowerShell tools as well that will do this. So PowerShell, there's a tool called Windows PowerShell Honeyports. This is actually on ADHD as well. So this is a script, just a little PowerShell script by John Hoyt and Carlos Perez. And essentially what this does is it's just the same as the netcat netsh option, but it's PowerShell. So, a lot easier to deploy. You can actually deploy this remotely on systems via like WMI, stuff like that, really easily. So same sort of concept. Right here, we're just simulating port 21. And then we're going to connect, right? We're going to connect using netcat over to this host. And so the first connection succeeded, as expected, right? And then right after that, we're blocked. So simple as that, right? And you can see in the logs, it verbosely logs all the activity that happens. So you can ingest this into whatever log management system you're using. So right here, you'll start to generate a list of these hosts. Now you can choose to not block them too and just start generating a list, and you can use this list later on to correlate back in time to see like what else these people have been up to. Like why are they poking around at these systems? Stuff like that. Now in Linux, there's an awesome tool called Artillery. This is by someone you all might know, Mr. Dave Kennedy. So you can actually download this here. It's just a free tool that you can run on Linux. It actually has a Windows binary as well. But the really nice thing with Artillery, it does kind of the same sort of thing. It just logs and blocks based on people connecting to whatever port you decide to imitate. But it also shoots back a bunch of junk here, which is kind of funny because sometimes you'll see people try and like actually figure out what this is. So you can waste their time, right? But the really nice thing with Artillery is there's lots of really great ways to pull logs from this. So by default, it just dumps the logs into the Linux syslog. So you're probably already pulling these logs. You can just add additional searches for Artillery, and then you can, essentially set up alarms and stuff like that off of that activity. So in addition to local syslog, you can also just create its own flat file. So you can have just an Artillery flat file log to essentially dump all these logs into. Or you can push to a remote syslog server. So a lot of ways to pull this data and push everything off to another host, right? And same sort of thing, IPs are added to the ban list and blocked locally. Now, a bonus feature within Artillery is it actually does a full system security check once you run this. So if you're like running your web server as root or something like that, it'll tell you. It'll give you a bunch of key indicators that like, hey, you don't have your system configured that well. So that's a nice feature as well. But one of my favorite parts is it comes with free built-in file integrity monitoring. So right here, we're just simulating basically creating a web shell. So we just uploaded our little shell.php files. This is what all attackers do, right? No. So now we have that file there, and we can tell within the Artillery logs that this new file was generated. And it creates a hash of the file. It sends us an alert that this file was added. So, just a nice additional feature on top of the honeyport activity itself. So anyone here run public-facing honeypots? Yeah? So this is probably not be anything new to you guys, but right here, I just like showing people that haven't really run honeypots just like how often your systems are hit when they're just directly open on the internet. This is like some random EC2 instance here, and it's just blown up. This is just less than a day of running just a honeyport on this host. So I just like people to see that, so they, it kind of helps get the point across of like, don't put RDP open the internet, or like, don't put SSH open the internet without SSH keys and stuff like that, because you're getting hit all the time. So that's kind of like reinforcing that point. So let's move on to low interaction honeypots. So low interaction, we're getting into like some of the web applications and stuff like that. So WordPot is a pretty neat honeypot. This one is very old though, so fair warning, if you're going to deploy this, you do want to customize it a bit, because like if you just spin this up and throw it out there, people are going to look at the README page and it's going to say like, oh, this is one from like, this is a WordPress site from the 90s. So you want to be a little careful there. But it's just a little small Python script that you can deploy very easily. And it just logs to flat files, so very easy to ingest into whatever your logging solution is as well. Phpmyadmin, another good service to fake, just because, like, how often do you check your logs and see Phpmyadmin sweeps against your environment? So if you're running like a fake Phpmyadmin interface that you let them gain access to, but it doesn't actually have a backend database, you can actually gather a lot of data from them just by, throwing like full packet capture on this host as well. So you can just see everything that they're hitting your host with. Sometimes you can actually get the full exploits as well, just carve them out of the PCAP. So this is a great way to do that. And this, same sort of thing, just logs to a flat file. And it's very easy to deploy on existing applications. Phpmyadmin is something that, is very popular. A lot of people use it because they don't really know how to admin their backend databases that well. So it's a very popular and a popularly misconfigured application out there. Now you can do this with any fake application. You can basically go out and clone whatever you want and weaponize it and turn it into a fake application. So right here what we're doing is we're simulating a fake VPN service. Anyone want to take a guess why we're simulating a VPN? No? Well, first and foremost, we want to learn what usernames this attacker has. So say like if they have real usernames, we want to know that. If they have real passwords, we want to know that. But the real reason that I decided to simulate a VPN, so we could run client-side code on them, right? So this isn't a VPN client at all right here. It's great. So we can run Java on their endpoint. So like once they're accessing this thing, you can do like reverse phishing to trick them into logging into this thing or whatever, like see if they're on a certain host. But once you get them to run client-side code, you can do stuff like this. So Honeybadger, anyone here play with Honeybadger? I think Tim Tomes, he's the developer of that. I think he's actually here. This is an awesome tool. What it actually does is it uses your wireless card to scan for all the other wireless networks around you, and then it uses the Google Location API to essentially pinpoint your location. It's very accurate, actually. So kind of here's an example of how this works, because attackers are never going to attack directly from their own systems, because it's just a bad idea, right? So here, we're going through Switzerland, just some proxy in Switzerland. But then we opened this document that we'd bugged, and we'd used Honeybadger to gather some additional data on, and it actually shows we're in Westminster. So pretty cool. It's funny how accurate this thing is. I was playing with it at my house, and it actually pinpointed my location to like exactly in my office, like where I was sitting. So kind of crazy. So with that, let's move on to medium interaction. Let's kind of go up the chain here. So there's tons of these. This is by far the most popular type of honeypot. So I'm just going to focus on one because this is my favorite one and one that I've gotten a lot of really good traction from, and that's Kippo. And so Kippo is very simple, just simulates SSH. So basically fake a Linux host on your network. Nice thing about Kippo is just a little Python script that you can heavily customize to look like all of the other Linux hosts within your environment. Looks exactly like whatever you want it to look like, and you can further customize the command output and all sorts of other stuff. So a very easy little tool to push out to multiple devices within your environment. The really cool part about this, it keeps standard flat file logs, but it also stores the full TTY session. Now what's nice about that is you can replay what the attacker did and what they saw and everything like that in real time. So you can see like all the commands they ran, you can see the output that they received, so you see like the whole picture. It also helps differentiate between like a bot and a real person, because you can tell like by the speed they're doing things, if they have typos, stuff like that. The problem with Kippo, though, is this is a very popular honeypot. So this is one that's been out for years now, and a lot of people have used this. Researchers have stood these up all over the internet. So attackers now know about this, and there's a lot of easy ways to quickly check that they've logged into a honeypot and terminate their session. So you just have to be careful of that. Like, this isn't one I would deploy facing the internet. This is more one I would stand up inside and just see if someone actually logs into it. Another risk with exposing these externally is that if someone actually connects to this thing, a lot of bots or a lot of bot networks will actually just log into these Linux hosts and they'll just stay logged in. That's what they do. And so this can incur a lot of additional costs for you if you're using like Amazon or something like that. So you just have to be cautious of that. And they'll also go and they'll try and attack other systems from this box. It won't work because they're in a Kippo honeypot, but it can still incur additional charges. You can also use Kippo as a pen test tool. So a fun thing to do with Kippo, if you're ever doing like an internal pen test, just stand one of these up on like your shared server that you guys are all logging into and stuff like that. Move the legitimate service, and then just stand Kippo up and just wait. Let it sit there for like a day or two, and guaranteed something's going to log into that box. Whether it's like a vulnerability scanner or a configuration management system or something like that, chances are something will log in, and then you can steal the credentials really easily. So here's an example of Kippo if no one's really played with it. So what we did here is we just ran our IP tables script, which essentially all this does is it forwards any request destined for port 22 to port 2222, which is where we're actually spinning up the honeypot. So now we're going to change we're going to change to our Kippo user. Oh man. Well, this is a good time. Oh, it's warm. I'm just going to let this demo play. Oh, this is awful. Oh, man. Cheers. Oh. Oh, man. That's terrible. That was a Smirnoff Ice. I think there's more if you'd like one. All right. So what all happened back here is we're using the Kippo honeypot, and essentially we tried some bad passwords and stuff like that. And that's essentially what I was showing in the back end here is the logs. Now this is the reason not a lot of people actually run honeypots, is because they don't want to go through this massive amount of data. That's why if you're going to do this, you should pull them into some sort of log management system so that you can go through and actually make use of this data, right? So down here, what the attacker's done is they just essentially got on the host, did some, basically figuring out where they are, some operational kind of, intelligence on the host that they just gained access to, and then they pulled down a file. The cool thing with Kippo is that once they pull down any malware to the host, it actually does store it in this DL directory. So you can go grab it later, hash it, compare it, stuff like that. So what I'm showing here is an alert that was generated based on the Kippo honeypot being breached. So whenever the honeypot's breached, you want to know about it. And so what I did here is I just replayed the TTY session and sent that over as an attachment to this email. Funny part, when I did this demo, this is actually a real attacker, like hitting our honeypot, so I opened the wrong one. So this is ours. This is the one we actually just generated. So that was unexpected, but so yeah, I didn't have it formatted right at the time either. But so once we paste it in here, we can see this is everything the attacker did and saw, presented to us neatly in the form of an alert, essentially. Now, if you want to check this out, I've cloned the Kippo repo. So if you want to check out my GitHub, I have a bunch of other scripts too that I've done to further augment the Kippo client, added some monitoring scripts and stuff like that as well. So if you want to check those out, there's my GitHub there. So let's move on to high interaction honeypots. Now, high interaction honeypots are essentially real systems. And the way we deploy them at Logarithm is in the sense that they're real systems. We put real systems on the internet, but we have dedicated monitoring. We've highly instrumented these systems so that we can see full command line access. We can see everything that's happening on the host, essentially. So just a few of the tools that we use to do this are, free tools are, well, these aren't so much free, but so in addition to whatever logging system you have, it's good to always be watching this data. But Suricata is a really cool IDS solution, and not just for, the traditional IDS sense. What we actually use Suricata for is we sinkhole the traffic. So whenever the malware is trying to call out, we sinkhole it, and we send it to Suricata, and Suricata allows us to actually interact with the malware. It creates a really cool ability to interact with some of the weird malware out there. Bro is the one that we do use more inline, as an actual IDS, where we actually try and block some of the traffic and try and see what's going on, right? And then Cuckoo Sandbox is essentially where we load our malware and explode it and gather some of that analysis from, right? Now, this is a fun project, Roman Hunter. This is the router manhunter. So you don't have to just use real systems to create honeypots. This one's essentially turning your router into a honeypot. So what this is you set up a real access point, and all it does is it waits for someone to connect to it successfully. So the fun thing here is you can set it either as secure or insecure as you want, and depending on how you want to gauge the attackers that are breaching it. Like if you set it with WEP and someone pops it, probably whatever. But if you set it like a WPA2 or something, and someone gets in, that's something like you might want to look into. So what this does is it takes their MAC address and just adds it to a list. And so you can take this MAC and you can correlate this back against your real environment and see like, oh, is this an employee or is this not an employee, or what is this? So that's like it's just a fun little honeypot that you can deploy on a router. Now we do have lots of warnings with high interaction honeypots because you're essentially using real systems. It's dangerous, so you have to have dedicated monitoring, someone watching this all the time. Because there's huge risk if you don't have someone watching this and ready to respond or ready to take the system offline if they start attacking other hosts or things like that, because that could come back to your company. You also don't want to deploy these even in your own IP space if you're, trying to do stuff like that out on the internet, right? So never use your organization's gold standard image when you're deploying a high interaction honeypot. I have a story about this. So there's this company who decided to deploy some honeypots, and what they did was actually put out real systems out in a DMZ that was under their control. And of course, RDP opened to the internet with a weak password. I think it was the day they put it up, it got breached. And so what happened is they got onto this host and they dumped the local admin hashes, and like the company hadn't disabled those, so they were not ready for honeypots at all. And they actually use that to pivot into the organization. So like deploying a honeypot caused a legitimate breach for this company. So you have to be very careful and make sure you really take precautions if you're going to deploy some of this stuff. And part of this is segmenting, and proper segmenting. So if you're going to put something out.
Hello folks, Iron Geek here. Unfortunately, the Avid Media froze up again, and we have no speaker audio or any video to speaker moving until about the 34 and 52nd minute mark. So if you fast forward there, you will see that the speaker starts moving again. You can hear them, but we do have slides in the meantime. Sorry for the inconvenience.
we can see they're on a Windows box. They have a little Asus tablet, tablet PC right there, using Office. So we get some good data on this just right from here. Now, of course, where's that IP address go? Of course, right? Why would it go anywhere else, right? Well, there is some more to this story. I can't talk about all of it, but this actually, the wire transfer, he did send this to a bank in the US, in California. So we actually reached out to this bank and we let them know, like, hey, look for this thing's coming through. We didn't actually do the wire transfer. We were like, hey, like, do you know this person and stuff like that. And actually from the Java, we could tell a lot more about this person. So it turns out the whole Nigeria thing, the LinkedIn, is not real. It was all a ruse, which is pretty genius when you think about it. They're using that to say, like, oh, Nigerian scam, they're going to stop right there. Pretty genius, if I say so myself. So what are some more things you can do to just screw with people, right? Screw with attackers and stuff like that. One of my favorites is just zip bombs. These are so fun. You can plant these like somewhere people might be trying to steal stuff or whatever. The thing with this zip bomb, if you go to unforgettable.dk, there's this file called 42.zip. It's like, I think it's like a 4.2 like byte file that once they expand it, it's like 30 different zips compressed in another zip. Like it's ridiculous. So it expands to like 4.2 petabytes. So if you like deploy this on someone, you're like, this will take out a supercomputer basically. So beef is another fun one. So if you're ever doing, like a lot of us are pen testers, so you probably use beef for, XSS, validation, stuff like that. But like when you own the environment and you own like where these attackers are in, essentially, you can just inject your own beef hooks and do like dynamic rickrolls on them and stuff like that, or like pop shells, or whatever you really want to do. Beef is an awesome tool if you haven't had a chance to play with it. Now, USB killer is another fun one. I actually haven't built one of these because I'm afraid to, because I don't want to like fry my computer, because that's what it does. It's essentially you take a USB and essentially turns it into basically a battery. Like all the details are here. Definitely check it out if you want to mess with this thing. But it's like it'd be the equivalent of you like plugging a USB directly into the wall and like into your computer. So, and then Clippy is always fun. This is actually on. Yes, Clippy is the best. Well, and the cool thing is you can do this with any images, really. It's just a Phpmyadmin feature, essentially. But I'd definitely check this out, because you can dynamically screw with people, and you can tick people off, but it's mostly funny, I think. And one of my favorites, though, this is like the dumbest thing ever, but it's so funny. Just cat dev random over netcat. So if you've never seen this is what it looks like. This is hilarious, because you'll get people sitting there for a long time trying to figure out what this is. So we're going to connect back to our, hey, there we go. That's all it does. It's funny, because they'll sit there like, what is this? We need to decipher this. It's funny, because they'll just waste their time for a long time. Now, if you want to take it to the next level, you can do full-on ASCII art. Like any So this is fun. I'd definitely check out this script down here. But essentially what this does, it allows you to play full movies through like telnet sessions and stuff like that. So we're going to connect to our file server here. And then we get rickrolled, right? In ASCII. Isn't that great? So now let's get back to, kind of the meat of everything we're talking about. Like the key to all of this, kind of what brings everything back together, is actually monitoring this stuff. So bringing it into some central management interface so you can actually watch what's happening and dynamically respond to what's going on within your honeypots and your real network. So you essentially want to bring in all your security tools. You want to have like at least a single pane of glass where you can see kind of everything that's going on. You want to be able to monitor your honeypots, and you want to be able to dynamically correlate that back with the real environment. So like they've been doing this over here in the honeypots. Well, what has this user been doing against real systems for like the past 30 days? I mean, that's just the stuff you want to try and tie the pieces together using honeypots kind of as the glue in between all of this. And once you have a very good network of kind of all of this stuff set up, you can actually start to create your own essentially enterprise threat intelligence. And so threat intel is like totally just way overused and stuff like that, but what I'm talking about here is context-aware threat intel. So this is like stuff that's directly affecting you and your unique industry. Because like if you're in retail, you're going to be hit by different stuff than say a hospital will. Hospital's going to be hit by different stuff than say the government. So like, you know, getting these giant threat lists of IPs, I mean, that doesn't do a whole lot of good. But if you generate your own like IOCs based off of what you're actually seeing in your environment, and then you share within similar industries, you can actually gain a lot of traction off of that. It all comes down to event correlation, right? Yeah. So now the next aspect is you actually want to automate your response to these threats. So one of my favorite ways of doing this is actually just dynamic honeypotting, like taking a system that's probably compromised or you suspect something weird going on and dynamically turn that into a honeypot. Now, there's a couple ways to do this very easily just by implementing command line logging. And I don't want to go into them too detailed, but there's essentially one registry value you have to set for the command prompt, and you can create a profile.ps1 file to audit PowerShell. Now, there's a really good link down here. So Michael Go, he actually presented earlier today. He has some awesome information on like detailed, verbose command line auditing. So I'd highly recommend checking that out if you want to implement some of this stuff. Now, there's also a lot of tools out there that'll help you with automating your response. So first one, Google Rapid Response. Pretty neat tool. Makes it very easy to kind of respond to threats and work as a team to share the intelligence you've gathered already. Netflix has their own project, Fido. Consa is a really cool PowerShell framework for incident response. And then Power Forensics is an awesome project. Actually, everything at InvokeIR is actually really cool. Jared Atkinson, I believe is his name. Really sharp guy behind like the whole InvokeIR project. So I'd highly recommend checking these out. But so I wanted to jump into the mix too with the whole incident response kind of thing too. So I wrote this little tool called PS Recon, just short for PowerShell Recon. Essentially what this is, it's a little script that we've integrated with our SIM essentially to go out and like say we see something weird like a crypto wall outbreak on a network. What we want to do is we want to go pull forensic data from this host and then knock it offline really quick so it doesn't spread to a share or something like that. So that's essentially the goal of PS Recon. You can also run it as a standalone script, and I like it. It does pretty well. But you guys should definitely check it out and let me know what you like and don't like about it. But one of the aspects we added into the tool is that when it does go pull data from a host, you can set up to send out email reports to the entire security operations team to let them know like, hey, like this host was just taken offline. Here's a bunch of forensics data from that host that we just pulled. And so it just sends out this email, and right here it actually gives you a full HTML report of all the data on the host. The nice thing about the report is everything's self-contained. It has images, base64 encoded directly into the page and stuff like that, so you don't have to reach out to another server to pull anything down. So makes it nice for quick and simple incident response essentially. So how do we bring all of this together, right? Everything we kind of just talked about. Well, one of the main things is Honeypot Dashboards. So actually being able to track everything that's going on in your honeypots in one easy to use way. HoneyDrive 3, one of the nice things about it, it has a ton of different dashboards in there. Basically, just about every honeypot that it has installed, it has a corresponding dashboard. So that's something you can go check out and like figure out what dashboards you want to use if you want to go like full open source or you want to do something with a commercial solution. It's a good resource to start with because then you can figure out like what honeypots will work for your situations. And then Kippograph is one of these. So since we talked about Kippo, I definitely wanted to mention Kippograph because this basically pulls all of the data that we were talking about out and shows in an easy to understand way. So like we were looking at the wall of text earlier, well, this actually helps make some sense of that. Now, the modern honey network, this is one we didn't really have time to talk about in detail, But this is a really cool project in that you can dynamically deploy honeypots and monitor them from one interface. As long as you have extra IP space, you can just keep pushing out more honeypots. And these actually use some of the more advanced ones like Dianea and Glassdoff and some of the really high interaction honeypots. So a pretty cool project. You should definitely check it out. And then of course, the best one, right? Logarithm. No one liked that one? Okay. Well, we'll just jump right into the data you should be collecting then. So, this is essentially a breakdown of a lot of the most important data that I like to collect in the dashboards that I use. So top attacking IP addresses. We want to see who's hitting these honeypots. And then the trending. We want to look at the trending of honeypot attacks versus the trending of the entire environment. So we want to correlate the two and see where the spikes happen and if they relate. Top usernames. Find out if people have real usernames that they're using, fake ones, stuff like that. Top passwords. Anything that looks like real passwords, you want to figure out. You want to dive into that and see oh, is this someone who actually had their credentials stolen? Stuff like that. And then honey token file access. So this isn't just limited to files, but tracking honey token access is something you definitely want to have right front and center. So say someone stole a document, moved it, did something else with it, you want to know about that. And so having that presented in a dashboard is a good way to do that. And then user agent strings. So user agent strings are kind of one of the more undervalued aspects that we're looking at here. Because user agent strings, you can learn a ton about the attackers. Because most people don't bother to change their user agent strings when they're attacking websites and stuff like that. So you can learn, if they're using tools to scan you, or if they're if they're just using their browser, if they're using a foreign browser or something like that, it'll give you a lot of intel on just what's hitting your environment. And then payloads. Any malware that's pulled down to the host, we want to track. And then directionality. So we want to figure out where they're coming from, where they're going, all that good stuff. And so from there, you end up with a decent dashboard covering your honeypots and your real environment, essentially. So with that, I just want to jump into some works cited and recommended reading. So most of what I talked about today is actually based off of some of the work that John Strand and Paul Asadorian have done. So I'd highly recommend their book, Offensive Countermeasures: The Art of Active Defense. It's a great read, and it's a very short book, but every page has really good content on it. So highly recommend that book. And if you're ever going to do IR, the Blue Team Handbook is a great resource because it's very short and simple, and it's precise to here's what you need to know for performing this sort of engagement or something like that. So very kind of straight to the point. Now if you want to get really deep into logging and log management, definitely check out Logging and Log Management by Anton Schwachen and Kevin Schmidt. That's if you're not into logging, it could be hard to get through, but it's a good read. It actually has some really good stuff if you want to build out a SOC in the right way and stuff like that. And then this last one, Reverse Deception, Cyber Threat Counter Exploitation. It's exactly like the name sounds. It's a counter intel book, and it talks all about how to deceive attackers and some of the tricks that CI folks use to deceive and trick people into divulging information and all sorts of other good stuff. So if you want to dig into any of this stuff anymore, definitely check out some of these resources. And with that, thanks. Any questions? I think we have some time for questions, and I'll be around. I got 3 minutes. Please exit to your left. Oh, yes. Yeah, I'll make my slides available. Yep, thank you. Hey, thanks, man.